Hoover Dam, a great engineering achievement and a true work of art, stands as a symbol of American creativity, achieved under extremely difficult conditions by people who were tough, resilient, and imaginative. But to most people, Hoover Dam represents something that is exceptionally big. And indeed, everything about Hoover Dam is large and impressive. For over 50 years, Hoover Dam has controlled the flow of the Colorado River, during which great quantities of water have flowed across the desert to Los Angeles, San Diego, and other great cities of the West. And irrigation water runs almost continuously into Coachella and Imperial Valleys. Since 1985, water has also flowed eastward to the cities of Phoenix and Tucson. And Las Vegas and its suburbs also receive most of their water directly from Lake Mead. For these cities, and for the irrigated crops of desert lands, the flow of regular water seems almost miraculous. But before Hoover Dam, the natural flow of the river was too erratic. None of the later projects built to actually deliver water would have been possible without Hoover Dam. Draining a vast region of the American West, the Colorado River collects water from the lofty mountains of 7 states. Then it flows through a succession of deep, spectacular canyons. Before dams were built on the river, much of the river's flow reached the Gulf of California. And all too frequently, it flooded into towns and agricultural areas, causing great damage. At other times, it was nearly dry. In 1916, U.S. government engineers and geologists began what was to be a 12-year search for the best site for a large dam. The dam would end the floods, and it would allow for future large-scale water developments. The dam was to be built in Black Canyon, where the Colorado River forms the boundary between Nevada and Arizona. This site was selected because in this section, the igneous rock walls were sound geologically. The canyon was deep, and the high dam at this point would provide tremendous water storage. Another factor was that it was reasonably close to the large power market in Los Angeles. It would be a federal dam, designed and construction supervised by the Bureau of Reclamation, an agency of the Department of the Interior. First among the thousands of construction tasks were the building of highways and railroad lines across the desert to the rugged canyon. New transmission lines for construction power were strung across 220 miles of desert from California. Working under hazardous conditions, the engineering forces completed their surveys in the spring of 1931 and declared that actual construction of the dam could get underway. But when construction of Hoover Dam started, America was slipping into a tragic economic depression. Unemployment was high and money was scarce. The news that construction of Hoover Dam would require thousands of workmen appeared like a brilliant comet across the western sky. Laborers, craftsmen, and their families from every state in the Union. The little town of Las Vegas was filled with excitement about the new dam to be built just 30 miles away. Men waited to sign up for employment, while their families waited desperately in whatever shelters they could find. Meanwhile, on a rolling hilltop 7 miles from the dam site, the town of Boulder City was rushed to completion in 15 months to house the army of 5,000 men to be employed. Boulder City was developed to be a model town, hopefully to furnish every facility and convenience to its inhabitants. The Bureau of Reclamation proclaimed proudly that the city had 4 churches, a modern, fully equipped school, and various civic organizations to meet the cultural requirements, while a theater and furnished recreation. The buildings housing the offices of the Bureau of Reclamation and the Civic Administration were set on the highest elevation in the town, adjacent to one of the public parks. White cottages of the married workmen appeared like military camps. Single men were housed in large air-conditioned dormitories, each accommodating 176 occupants. No one had much luxury, but it was clean and livable housing. During this early period of the job, before roads had been built into the depths of the gold, and materials were ferried to the job sites by boat. Men also crossed the swift, muddy river on swinging catwalks suspended between the sheer canyon walls. The summer heat was intense, often over 120 degrees. During the worst hot spell of 1931, workmen in the canyon began dying of heat prostration at the rate of one almost every other day. The management finally discovered that the men were simply not drinking enough water. From that time on, water, even ice water, was regularly delivered to workers by a fleet of water carriers, and the deaths and the suffering were greatly reduced. To prepare the canyon walls to receive the abutments of the dam, many tons of rock were removed by daily blasting with dynamite, and the procedure was often spectacular. After each blast, the high-scalers swarmed over the face of the cliff to remove the dangerous fragments of rock shattered and loosened by the explosion. One of the most difficult phases in the entire project was the boring of diversion tunnels to carry the river around the dam site during construction. Drilling was conducted around the clock in sweltering heat, where the air was often contaminated by dangerous fumes. To drill the huge tunnels, large drilling rigs called jumbos were mounted on large trucks and backed to the rock face. The jumbos, complete with long drills, workmen, and helpers, were capable of driving from 24 to 30 powder holes into the heading simultaneously. But the noise was almost unbearable. Thousands of tons of drilled steel were used in this work, and the sharpening shops were kept working night and day to maintain a steady supply. This drawing of the canyon at the dam site shows the Colorado River flowing left to right. The 4 big diversion tunnels, 2 on each side, were to be cut through the canyon walls for a distance of about 4,000 feet. Each tunnel would be 56 feet in diameter. During the construction of the dam, these tunnels would have to carry whatever flows came down the river. Long lines of heavy-duty trucks, each handling from 8 to 10 tons of rock, labored up over steep roads cut into the canyon walls to dump the material into gulches near the dam site. After the tunnels had been excavated, they were lined with 3 feet in thickness. The drilling of the tunnels, together with the concrete lining operation, all completed within a period of 13 months, was considered the most grueling portion of the Hoover Dam construction for both men and machinery. In November 1932, during seasonal low flows, the river was diverted through one of the tunnels. A small blast opened a breach in a temporary dike, creating a channel for the flow of water into the 50-foot diameter concrete-lined tunnel. A temporary dam of earth and rock was quickly thrown across the river, deflecting the entire flow into the tunnel. Within 24 hours, the entire flow of the Colorado River flowed around and past the dam site through one of the diversion tubes. This event was a significant milestone in the Great Project. To make sure that anticipated high flows of the river would not flood into the dam site, more than 1 million cubic yards of material went into the construction of the two cofferdams, in themselves large earth dams. The tunnels and the cofferdams were built to de-water the dam site. The design was simple but extremely difficult to accomplish. The largest cofferdam was upstream, while a smaller cofferdam was built downstream to keep the river from backing into the dam site. The plan proved highly effective. The river flowed around the dam site and caused no problems during the completion of the dam. After the cofferdams were built to a sufficient height, the actual dam site was de-watered, and a fleet of power shovels and trucks began work on the excavation of the riverbed material. Only bedrock would provide a solid foundation for the heavy dam. This excavation required the handling of more than 2 million cubic yards of rock, earth, and sand. As the cleanup of the dam site progressed, the bed of the Colorado River was laid bare. Here, geologists were able to determine that thousands of years ago, Black Canyon had been even deeper. Then, as geologic time progressed, the deepest inner channel was slowly covered by over 100 feet of river deposits. To ensure stability for the foundation of the dam, all loose rock and sand were washed away before the first concrete arrived. 12 miles from the dam site on the Arizona side, men and machines opened up the aggregate pit, from which sand and gravel were to be obtained for the 4.5 million cubic yards of concrete required for the construction of the dam. Here, the raw material was excavated by dragline and hauled by train to the gravel screening and washing plant, which was capable of producing 20,000 tons of crushed, screened, grated, and washed material every 24 hours. Arriving at the plant, the raw material was dumped into hoppers, from which it was moved into the plant by conveyor belts. The material then passed through various stages of screening. Oversized rocks, that is, those measuring more than 9 inches in one dimension, were first screened out, then crushed and returned to the plant for regrading along with raw material. The plant itself consisted of 4 screening towers, each separating out gravel of a different given size from the raw material. The selected material was stockpiled separately, ready at hand when needed at the mixing plant. A clarifier tank provided 6 million gallons of clear water daily for washing gravel and sand. Sand was graded a second time into 3 sizes after the very fine and undesirable sand had been discarded. The 3 selected sands were then recombined into a uniform mixture determined to meet specifications for the finished concrete. As the graded sand and gravel were called for, they were conveyed by railroad cars to the concrete mixing plants located at the dam site. At Black Canyon, mass concrete was first mixed in a plant in the bottom of the canyon. Then, after the dam was about 1/2 its full elevation, most of the remaining concrete was mixed in a plant on the canyon rim. Bulk cement was unloaded from railroad cars by a suction pump and conveyed into the bins where cement from several different production sources were combined into a uniform product of predictable workability, strength, texture, and color. In the mixing plants, the several ingredients were carefully combined into finished concrete. Each of the two plants had a maximum capacity of 24 cubic yards of concrete every 3½ minutes. Here, automatic equipment controlled the apportionment of the concrete ingredients and maintained a graphic record of every plant operation. The major portion of the concrete handled on the project was transported from the mixing plant by electric train. From the train, it was transferred to 8 cubic yard buckets to complete its journey. A system of 9 aerial cableways spanning the canyon from rim to rim and anchored at either end to movable towers was used to transport the concrete to the rising dam. On June 6, 1933, the first 8 cubic yards of concrete were poured in the lowest of the dam forms, 135 feet below the level of the river. What was to become the highest dam in the world thus began its slow, ponderous rise from the solid foundation rock. And soon the rising concrete blocks extended upstream to downstream a full 660 feet, representing the thickness of the dam. The concrete was poured in blocks in successive layers 5 feet thick. The layers were called lifts. In spite of rumor, no one was buried in the concrete. Since an entire crew always watched the dumping of each bucket, any accident would result in fast, corrective action by the men. But no accidents of this type were recorded. Concrete was compacted into the forms by mechanical vibrators, assuring dense compression against adjacent surfaces. Work continued under all conditions, at all seasons of the year, without cessation, rain or shine, both day and night. Transit mixers were transported on trucks from the bed of which they could be removed and handled on the overhead cableway. These were used in the pouring of concrete in the confined forms along the abutments. A 24-hour day was divided into 3 shifts of 8 hours each. The 4th of July, Labor Day, and Christmas were the only holidays observed. Many Hoover Dam laborers and craftsmen stayed on the job during the entire period of construction. For most of the workmen, some of the best parts of each day were spent in eating. Tons of good food were prepared and served daily in the clean, efficient kitchens. Cooks and waiters were able to feed as many as 1,300 men at one setting of the tables. The men were told to eat as much as they wanted. As most of the workmen lived in Boulder City, 7 miles distant from the dam site, necessary transportation was provided by a fleet of passenger motor trucks, and some of them could carry as many as 160 men. Workmen were usually lowered from the canyon rim to the dam forms by way of the inclined monkey slide, as it was called. But to get to a place quickly, there was nothing as exciting as a quick ride in a skip, swung from a small cableway called a Joe McGee. Industrial accidents did occur at the dam, in spite of strong efforts to prevent them. 96 men were officially listed as killed on the job. Actually, the count may have been higher since some of the records are confusing. One of the most interesting and spectacular phases of the work was the fabrication and installation of the huge steel penstock pipes that would conduct water under high pressure to the power plants and to the river outlets. This work was performed by the Babcock and Wilcox Company of New York City, which erected a complete steel fabrication mill on the canyon rim. The plan called for manufacturing pipe and penstocks from steel plate varying in thickness from 5/8 of an inch to 2 3/4 inches. As it was impossible to ship units of this size across the country by rail, steel plate was brought from eastern rolling mills, and the entire process of manufacture was conducted at the Hoover Dam plant. First step in the fabrication process was the shaping of the edges to ensure the precision and accuracy of later steps in their manufacture. This work was done on a planing machine capable of handling a strip of steel 50 feet in length. Plates for penstocks 2 3/4 inches in thickness were given an initial bend on a giant press operating at a pressure of 3,000 tons. This initial bending was necessary to avoid damaging the plates in the next step of fabrication. The plates were rolled into circular form by 40-inch vertical rollers, which imparted the desired degree of curvature. 3 curved plates were then joined to form a single ring, 30 feet in diameter and 11 feet long. 2 such rings were then joined end to end to form a unit 22 feet long and weighing 170 tons. These rings were joined by rotating them beneath an electric welding machine. Every foot of welded joint was then subjected to an examination by X-ray and recorded on photographic film, which exposed any imperfection. Samples of typically welded joints were subjected to rigid laboratory tests, calculated to produce strain far greater than expected under actual usage. Even a small imperfection was sufficient cause for the rejection of a complete unit. Heavy-duty rigging was required to handle the sections through the shop, and high-capacity cranes were required to move them step by step through the progressive phases of their manufacture. To equalize the terrific internal strains introduced into the plates by bending, individual pipe sections were heated to a temperature of 1,400 degrees Fahrenheit in a gigantic annealing furnace. As these sections were to form a continuous penstock, provision was made to have them ready to be joined in the tunnels. To guarantee a tight seal, the ends of the sections were machined on a mammoth vertical lathe operating across the 30-foot diameter of the pipe. After a final inspection, the pipe section was ready for installation. A train of the 1930s passing through one of the huge tubes affords a gauge for the size of the units. The job of transporting the pipe sections from the plant to the dam site required the construction of a special road trailer capable of carrying 200 tons. A bulldozer furnished the motive power. The trailer was equipped with air brakes and power steering. Upon arrival at the canyon rim, directly over the dam site, each unit was maneuvered into position for lowering into the canyon. This was one of the first major tasks for the permanent 200-ton capacity cableway that still performs excellent service over half a century later. The 6-track cables on this cableway are each 3 1/2 inches in diameter and stretch over the canyon a distance of 1,256 feet. The cableway was manipulated from a control tower overhanging the canyon, from which the operator could view all its movements. A specially designed heavy-duty rig, which became known to workmen as the moonbeam because of its peculiar shape, was used in lowering the huge tubes into the low levels of the canyon while cradled in a sling of heavy steel cable. While the dam neared completion, so also did the intake towers, which were seen as a maze of reinforcing steel rapidly rising toward the uppermost rim of the canyon. These towers each contain mammoth cylinder gates. Perched on shelves cut into the canyon walls, the 4 intake towers, each over 400 feet high, now serve as inlets to the 4 steel penstocks supplying water to the turbines and outlet valves. Altogether, Hoover Dam has over 3 miles of huge pipes and penstocks. The dam had already become a prime tourist attraction for thousands of visitors. During 1934 and much of 1935, an uninterrupted stream of concrete was poured into the forms of the dam, and block by block, the massive concrete of the dam rose slowly until it reached crest elevation, 726 feet above bedrock. And as the thickness of the dam narrowed, the width between the abutments widened considerably. Here is an unusual sequence of impressive still photographs taken from roughly the same point over a period of 4 years, showing the diversion of the river, the excavation of the foundation, and the slow rise of Hoover Dam. In June 1935, the dam structure itself stood completed, 2 1/2 years in advance of the time originally designated. In September of that year, President Franklin D. Roosevelt dedicated the dam to the progress of the nation.
That is why I have the right once more to congratulate you who have builded Boulder Dam, and on behalf of the nation, to say to you, well done.
The roadway traversing its 1,300-foot crest was made a link in US 93 connecting Las Vegas to Kingman, Arizona. The reservoir filling behind the dam was named Lake Mead in memory of Dr. Elwood Mead, late Commissioner of Reclamation, whose life work culminated in the building of Hoover Dam. The largest artificial body of water in America, it extends upstream 115 miles into the lower reaches of the Grand Canyon, with a shoreline of 550 miles. Construction of the power plant, a U-shaped structure at the downstream toe of the dam, had been in progress for some months, so that there would be no delay in power generation. Within the power plant, the first generator was placed in operation in 1936, while the last of the 17 generating units was installed in 1961. Transmission lines carrying Hoover Dam power radiate in a network from the dam, with major lines serving the Los Angeles metropolitan area. From the takeoff structure located on the roof of the powerhouse, the lines soar upward over the rim of the canyon into the switchyard, then out into the desert. Hoover Dam stores water that is used for irrigation throughout the entire year in the warm valleys of Southern California and Arizona. The water also supplies several major metropolitan areas of the Southwest. A series of dams along the Colorado below Hoover Dam, as well as huge canals, play major roles in this dramatic movement and distribution of water. Located at the ultimate high water storage level of the reservoir, the two spillways designed to act as overflow controls in the open bypass system were located one on each side of the canyon, upstream from the dam and within the reservoir area. Work on their construction progressed simultaneously with that of the dam itself. In 1941, the spillways were tested, but were not used very long. Then in 1983, a large and unpredicted snowmelt runoff caused a rapid rise in Lake Mead, and the spillways had to be used for over 2 months. Those residents and tourists who had the once-in-a-lifetime opportunity to see the spill of water up close said that the experience was breathtaking, as well as very, very wet. The story of Hoover Dam weaves together thousands of stories, one for each man, woman, and child who participated. Most of them were heroes in some way. Collectively, the Hoover Dam story is a chronicle of human achievement rarely equaled in history.